Right. So who has the answer to this? So let me not waste time. 1 times 1 is 1 plus 3 times 0 is 0 plus 2 times 5 is 10. So this is 11. 4 times 1 is 4. 4 times 1 is 4 plus 0 times 0 is 0 plus 1 times 5 is 5. So this is 9. So we have 9 here, 11, 9. 1 times 3 is 3 plus 3 times 1 is 3 plus 2 times 2 is 4. So this is 10. 4 times 3 is 12 plus 0 times 1 is 0 plus 1 times 2 is 2. So this is 5. So this matrix times this matrix is going to give us a vector 11, 9. Sorry, matrix 11, 9, 10, 5. Okay, I told you this is 2 by 3 and this is 3 by 2. So this will give us a 2 by 2 vector. Does that make any sense? Does that make sense? Hello, anyone? Is anyone here? Does this matrix multiplication make sense to you? Or I should go over it again? This is a 2 by 3 matrix. This 1, 4, 3, 0, 1, 2, 1, right? And this is a 3 by 2 matrix, 1, 0, 5, 3, 1, 2. For you to multiply, you can't multiply this matrix by this matrix. The only way you can do it is to separate this one into two vectors. So this is one vector, this is another vector. So multiply this vector by this matrix, which is what we did here, by 1, 0, 5. We got the vector matrix multiplication, right? Then we multiply this vector again by this matrix, which is what we did here, right? So we got the vector matrix multiplication, then and that gave us our final answer. Does that make sense? Hello, does that make any sense? So you're asking that question because you were in that the matrix multiplication class. So this is how we did it. In matrix vector multiplication, we'll take this plane, right? We take this plane and multiply it by this plane to give us this. So 1 times 1 is 1, plus 3 times 0 is 0, plus 2 times 5 is 10. So that's 1 plus 0 plus 10. That gave us 11, right? So 4 times 1 is 4, right? Plus 0 times 0 is 0, plus 1 times 5 is 5. That gave us 9. 1 times 3 is 3, plus 3 times 1 is 3, plus 2 times 2 is 4. That gave us 10 here. Then 4 times 3 is 12. 0 times 1 is 0, plus 2 times 1 is 2. That gave us, wait, what am I doing? 4 times 4, no, I'm wrong. 4 times 3 is 12, plus 0 times 0 is 0, plus 1 times 2. This should give us 14, rather. None of you were able to correct me. So this should give us 14. Does that make any sense? So that's how we got our matrix multiplication. Do you understand it now? All right. So in absence of any questions, We are going to take the next topic, which is identity matrix. So our identity matrix, which you must have heard of, looks like this. We have 1, 0, 0, 1. So this is 2 by 2 identity matrix. We have 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is 3 by 3 identity matrix. Then we could have 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. This is a 4 by 4 identity matrix. Does this make any sense to you? So once you say a matrix like this, they are called identity matrix, and we use them to take matrix inverses. I don't think I have time to prove a matrix inverse to you, right? But let me just show you what we mean. So let's take a vector inverse, for example. So vector inverse and transpose. So you know that in usual mathematics, right? If we multiply 3 by 3 raised to power minus 1, what does it give us? Chorus answer. Three times 3 raised to power minus 1. You said what? Wrong. Anybody else wants to try? 3 times 3 raised to power minus 1 is just basically saying 3. Just basically saying 3 times 1 over 3. That's 1. And that example, if we have 12 multiplied by 12 raised to power minus 1, what does it give us? Good. Why this was important is because we use this to find the inverse of a matrix. So let's say we had a matrix 3, 2, 4, 16. If we wanted to find the inverse of this matrix, what we need to do is relate it to. So let's say this is A. This is vector A. Now, vector A times vector A raised to the power minus 1 will give us 1, right? This will give us, oh God. This will give us 1, 0, 0, 1. So vector A times the inverse of this matrix, right, is going to give us the what do you call it again? The identity matrix, the 2 by 2 identity matrix. So we need to do a transpose for you to get this, right? So I'll just give you the answer for this. This is 0.4. This is minus 0.1. This is minus 0.05. And here we're going to have my 0.075. So this is the inverse of this matrix. We don't need to get to the point where we are going to get this, but I need to understand this concept that multiplying this by this is going to give us the identity matrix. The last thing we are going to treat for today and for this class, or for intro to linear algebra, is matrix transpose. Before we go to determinant, sorry, the second to the last thing. So matrix transpose. And I mean, it's just very simple. Transpose it, because we're going to need this in the next class, right? So matrix transpose is like just saying, if we have a vector A equal to 1, 3, 2, 5, 0, 9, right? This is a 2 by 3 transpose, 2 by 3 matrix. If we are going to transpose it, it's going to become a 3 by 2 matrix. So transposing this is going to give us what? This was on this plane, it's going to come to this plane. 1, 2, 0, then 3, 5, 9, right? So this is because a 3 by 2 matrix. This is just what this is just what transposing the vector a matrix means. Very easy. Because it's this easy as well, we're not going to take more than one example. And I'm going to go into the last, but a little bit complex part of today's class, which is the determinant of a matrix. Oh. So as a matter of definition, write this down. A determinant is a scalar derived from a square matrix. This will look like what we did in the matrix vector multiplication operation, but it's a little different. So let me give you another example. Or first, let me give you the formula. So if we have a vector, sorry, a matrix. If we have a matrix A, C, B, D, right? The determinant of this vector is this way first, then this way. So the determinant of this vector is going to be AD minus BC. Does this make sense? So let's take for example, vector or matrix 1, 3, 2, 4. The determinant of this vector is going to be 1 times 4. That's 4. Minus 2 times 3. Minus 6. The determinant of this vector is going to be minus 2. Right? If you understand that, give me the determinant of 4, 7 minus 3, 2. What's the determinant? What's the determinant of this vector? Of this matrix, rather? Okay, correct. All right, that's correct. So let's go into the determinant of a 3 by 3 matrix, which is a little more complex. But let me give you the formula for that. Right. So we have plus, minus, plus, and we have minus, plus, minus, and we have plus, minus, plus. So put this formula down somewhere. So if we have a vector A, B, C, vector D, E, F, and vector G, H, I. The determinant of this is you first take out this plane, take out this plane, and also take out this plane. Then you solve for the plane that is left. So determinant for this is A into E, F, H, I, right? Because A is plus, right? Minus B, B is minus. So minus B into, once you take out this plane and this plane, we're going to be left with D, F, G, I. So D, F, G, I plus C. Plus C is in a plus, so plus C into, if we take out this plane and this plane, that will be left with D, E, G, H, right? So this is D, E, E, sorry, this is G, right? This is DG, EH, EH. So this is how you find the determinant. So basically, as a way of solving, making this more generic, this is going to be A into brackets. Don't forget it's this minus this. So this is going to be EI. Let me make it look a lot more. EI minus FH minus B into GF. Okay, it's not GF. Then it's go the opposite way. Here we add EI, right, minus FH. Then it's go the opposite way now. So it will be GF, sorry, DI minus FG. So this is DI minus FG plus C into DH minus this. So here we add falling diagonal minus rising diagonal. Here we'll have rising diagonal, right? Okay, sorry, it's falling, no? Falling minus rising, then falling minus rising as well. Right, so F minus R, F minus I, F minus R. So we have DI minus FG, then we have DH minus EG. Does this make sense before we go to the example? Right, let me go to an example now. We'll take only one example, then I'll give you an assignment. The assignments will be submitted before we take next class because I want everyone to be on board, right? So we're going to have an example here. So 3, 1, 2, 7, 0, 4, and 5 minus 1, 0. Can you get your hands on this determinant of this matrix? Don't forget we had plus, minus, plus here. So this is going to be 3, A, 3. I'm going to solve it once and for all because I don't have time. So I'm taking out this plane. So I'm left with only this plane, right? So 0 minus 0 is 0, minus 1 times 4. That's 0 plus 4, right? This is minus, so this is minus 1 into, right? So this is 0, 0 plus 4 minus 1, right? Minus 1. So I'm taking out this plane and I'm taking out this plane. So I'm left with 7 times 0 is 7, minus 5 times 4, that's 9, right? I want to take out 7 minus 9. 7 minus 9. This is plus 2. Plus 2 into, so I'm taking out this plane. Yeah. I'm multiplying. Let me take this plane for example. I'm multiplying 7 by minus 1. That's going to be minus 7. Minus 5 times 0. That's 0. Does it make sense? Sorry, hold on. 7 times 7. Wait, hold on. That was this, right? That's 704. This 7 times 0 is 0, right? Sometimes I just sleep. 7 times 0 is 0. Sorry about that. Then minus 5 times 4 is 20. Thank you for calling me back. Yeah. So for here now, 7 times minus 1 is minus 7. Then 5 times 0 is 0. So that will be minus 7 minus 0. So at the end of the day, we have 3 times 4, which is 12, minus, this is going to be plus 20 because minus times minus, right? So this is minus 20 times minus 1. That's going to be plus 20 plus 2 times minus 7. So it's going to be minus 14. So the answer to this would be 32 minus 14. That would be 18, right? Did everyone arrive at 18? Hello, did everyone arrive at 18? I need feedback, guys. Hello, guys. I've written and stopped recording again. So here's my assignment now. 4, 8, 4, 8, 13, 7, 1, 4, then 2, 3, 9. So find the determinant of this matrix, and then let's discuss it on Monday morning. So that'll be the end of this class. All right. Thank you so much. See you on Monday. Okay. Okay. 4, 8, 13, 7, 1, 4, then 2, 3, 9. Mm-hmm. So that'll be the end. Thank you so much.